The pendulum of a grandfather clock swings with a periodic motion that can be represented by the trigonometric function here. Big thing you should notice here, this is in radians. Your final answer has to be in radians. You can do all your workings in degrees, I'm happy with that, but your final answer, your x-axis, has to be in radians. Sketch 2 cycles of the graph. I always do a mapping rule with my original points. I know a lot of you do not. Some of you use that other thing in the notes, that's fine. So your cosine graph, the original points are 1, 0, minus 1, 0, 1. And I'm using my mapping rule xy to x plus pi over 3 changes to minus, and I'm going to change this to degrees while I find out my answers. So your new points, some of them are pretty big, don't panic. It's just because I have a stretch factor of 2, which means my graph is getting super wide. So my first point, when I plug in 0, I have minus 60 and 5. 120 when I plug in 90 here, and 3. 300, 1. And then my graph starts to go back up. So if I was to draw a graph, some of you do your axes different, not a big deal, don't panic, life's good. I know 5, 3, and 1 are my important points. I know at negative 60 degrees, I'm at 5. Then at positive 120 degrees, I'm back down to 3. 300 degrees, I'm back down here. 480, I bump back up, and you're following this motion. Up top. Now, how would you find the next point? Look here, I'm increasing by 180 degrees every time. So you're just going to add 180 on to that. That is 840, I think, 840. And then you add 180 onto that again, so 1020. And you get this beautiful graph. Right now, that's not two full wavelengths, so you do have to keep going. You can move to the left or move to the right, as long as you have this here. When you draw your dots, make sure it's a wave motion. It doesn't have to be perfect, but I don't want any triangles. You do have to know a sinusoidal function is curly. And you also need to have 2 full cycles of your graph. So I start at the top, I need to have at least 2 tops. If I start in the middle, make sure you go 1, 2 full rotations. Your original question was in radians, so when you have your final answer, these should be in radians. So make sure you go through and change them all back. Positive 2 pi over 3, and so on and so forth. You can fill in the rest of those values. Just multiply each of these by pi over 180. If your original equation was in degrees, you can leave your answer in degrees. That's perfect. What would be the height of the pendulum after 2 seconds? You're taking your original equation, h of 2, equals 2 cosine a half, and you're filling 2 in for your t value, your time value. You can just plug this into your calculator and get a decimal. So a half bracket 2 plus 3.14 over 3, you're going to get a decimal for here, cosine of that number. So really, if you have a nice calculator, like one of those Casios or graphing calculator, you can chuck all of this in and get your solution. It's around 3.14. You might get 3.09, you might get 3.15. As long as you're around that value, I'm happy. So you're just plugging it into your calculator. 2 cosine of whatever that decimal is plus 3. Okay, there's no solving. It's just an easy plug and chug. Question 13. Determine the equation of the sinusoidal function as a transformation of cosine and sine. So when I look at this, I always look at my amplitude first. It goes up 2. My midline is negative 1. I should also find my period. Some of you guys had trouble with that. I go off similar points, so from here to here. You should be able to look at this and say, okay, that's 45, this must be 30, this must be 15. It's split into 3 sections. So the distance between positive 30 and negative 90 is 120. You can also see it from here to here. This would be a 120. The distance is 120. So you have most of the stuff for your equation. I do know I need to find my b value. B is 360 over your period. So 3. So y equals 2 sine 3 X. Look at your phase shift. There's actually no phase shift for my sign. This is my middle going up. You could take this 120 and put plus 120, or you can take 0. So you could end up here. And then your midline, y equals 2, cosine 3. Your phase shift, you need to pick a top. You could pick positive 30 or negative 90. I'm going to pick the 30. But you could also have x plus 90. That's not wrong, it's just different because you're picking a different starting point. Not a big deal, exact same solution. Beautiful. Last guy, determine the general solution to this equation. Always take whatever's in your sine or cosine and replace it by an a. It just makes the solution a little tiny bit easier to see. I need to minus 4 from both sides, so I have negative 1 equals 2 sine a, which means I'm solving for when sine a is negative a half. Draw your picture. To find your reference angle, find your reference angle, you're going to do sine inverse 1 of positive a half, and you get 30 degrees. But your sine value is negative. Sine is negative here and here. If your reference angle is 30 degrees, that means this guy's 330, and this guy is 210. So your solution is A is 210, A equals 330. Don't stop here. You've replaced something with A at the beginning, which means I need to plug back in what I was given. So I'm plugging back in 3x plus 30 equals 210. 3x plus 30 equals 330. Divide both sides by 3. X plus 30 equals 70. And then minus 30 on both sides. X is 40. Same thing over here. Divide both sides by 3. X plus 30 equals 110. Minus 30. Minus 30. X equals 80. It wants the general solution. So I'm just going to hop up here and write it in. You have a 40 and an 80. And you need to add your period and an EI. Your period and an EI. This solution is allowed to be in degrees because it was a degree there. If it was a radian here, at this point you should start changing it back into radians. Okay? Nice hint for your test. If it's a radian there, make sure your answer is radian. This is always going to be your period. Your period is 360 over your B value, which was 3. So 120. Make sure if this was in radians, you change it to radians in your general solution. Last guy. Determine all solutions within the domain. 0 is less than or equal to x is less than or equal to 30. You start off with these values from your general solution, and you add or subtract your period until you bust outside your domain. So I have 160, that's within the domain. I have 200, that's within the domain. If I keep adding 120, I get 280, that's within the domain. If I added another 120, I'm at 400, so I'm outside. Same thing here. Add 120, I get 320. If I added another 120, I'm outside the domain. I'm not subtracting because my bottom part is 0, but I could have given you like negative 180 and you would have had to subtract 120 as well. It's an option. Okay, so this is your final answer for that guy because I can't add anything else or I'm outside my domain. The 40 and 80 are technically also solutions. It's just without adding or subtracting 120. It's just your regular ones. Perfect. I don't have enough time to do the other version. I did upload the answer key to Google Classroom. Any trouble, send me an email. I'll try and get back to you as soon as possible. Thank you.